This is a quick review of the three different kinds of factoring that we've done. Now this is common factoring. This is a bit of a complex, more of a complex kind of question. A lot of the ones we see are a lot more simple than this, but this gives us a good idea of what these questions look like. So the first thing I'm going to do is I'm going to look at the numbers, the coefficients of every term, and I'm going to decide what's a common number that divides into all of them. You're going to find the biggest one because you're looking for the greatest common factor. And so 2 goes into everyone. They're all even. 4 goes into all of them. 6 goes into some. 8 goes into others. It looks like 4 is going to be the biggest, so I'm going to take out 4. And then when I look at the variable part, I see that there's an x in each of them. So the biggest x that I can take out of all of them is x to the 3, because I can take x to the 3 out of this, and this, but I can't take any more than x to the 3 out of that one. So that's the most I can take out. Then I do a bracket, and I find out what happens when I divide that out of everything. So 12 divided by 4 is 3, and x to the 4 divided by x to the 3 is x. Negative 20 divided by 4 is minus 5. X cubed divided by x cubed is 1, that's gone. And 24 divided by 4 is 6, so plus 6. X to the 5 divided by x to the 3 is x squared. And I can look at what's left, and I can ask if there's anything else in common. If there is, I didn't get the GCF originally, but it looks like I'm good. It looks like I'm done. There's nothing else in common, so it looks like that question's finished. Now, a more typical question would look probably something like this: x squared plus 4x, and all I would do is take out an x. Remember doing these when we were doing a lot of factoring, and you're left with just x plus 4. And then again, if I multiply the x back through, I'll get back what I started with. So that's the idea. One that's just a little bit more complicated maybe would be something like 3x squared plus 9x. And so I can take 3x out of each of those, and I'm left with x plus 3. And again, if I multiply it back through by both, I should get back the question that we started with. So these two over here are slightly more common versions of the common factoring, but this one shows us exactly all the little details of how that one works. The next type is a trinomial. So if you remember doing the number game, two numbers that add to this and multiply to that, that's what the trinomial type is like. And one of the tricks is you have to remember which number they add to and which one they multiply to. And then there's lots of other little things. You practice a little bit, you get pretty good at it, but you got to watch for the signs. You got to think about all the little details. So again, you can go back and watch another video for a more in-depth look at this. But it's two numbers that multiply to 24 and add to 5. And because the thing that they multiply to is negative, they're actually going to have a difference of 5. So what two numbers multiply to 24? Start listing different pairs of numbers in your head that multiply to 24. 12 and 2, 4 and 6, 24 and 1, 8 and 3, and then think of which of those pairs have a difference of 5. And it's 8 and 3. So I'm going to write it like this, and then I think about which one do I want to be negative and which one do I want to be positive. And negative 8 plus 3 gives me the negative 5. So that's the right answer for that one. And then if you had even a more simple question, something like this: two numbers that add to 7 multiply to 12, x plus 3, x plus 4. Everything's positive, so they just 3 times 4 is 12, 3 plus 4 is 7. So that's one where everything's positive. It's a little bit trickier when you have the negatives. There's a couple of examples of that. The last type is the difference of squares. Again, this one's a little bit trickier, a little bit more complex than a lot of the ones we saw. But one of the things is recognizing a difference of squares. So it's two terms, and there's a minus sign between them, and everything's a perfect square. So 16 is a perfect square, 25 is a perfect square. And I write it like this, and one of them is plus and one of them is minus. And I take the square root of the whole first thing. So the square root of 16 is 4, and then x squared is x, and I write that, in both brackets, and then the square root of 25 is 5, and I write that in the second spot in both brackets. So again, a more simple version of this would just be like x squared minus 9, and you would get x plus 3, x minus 3. But a little bit more complex one is when you have more numbers or more variables or more parts to it like that. And then the last thing is making sure we can identify which types. So we already talked a little bit about what makes a difference of squares a difference of squares. Two terms minus sign between them, everything's a perfect square. Trinomial is easy because it's got 3 terms, 1, 2, 3. And it can be a common factor when you have 3 terms, but this one's common. It's got an x squared, an x, and then just the number, the constant. That's telling me it's a simple trinomial. And then the common factor could be any number of terms, but probably only 2 or 3 really for us. And really what you're looking for is if there's a bunch of numbers, if everything's got numbers and everything's got variables, and the numbers have a common factor in them, so they're all multiples of 2 or they're all multiples of 3 or 5 or something straightforward like that. That's what you're looking for a common factor.